All right, click them all the way closed. I want earbuds out, phones away. I want to go through a little review with you. I think there'll be some time to get a little work done here. Compound inequalities is what we're going to talk about today. So you guys have been working on regular 5.1 assignments, just about solving regular simple inequalities. Compound inequality is just, compound means more than one of something. So a compound inequality just means more than one simple inequality at the same time. Okay? Oh, did you get these things, by the way? Did we get the handouts? Did you not? Oh, I wrote it out. Oh, hold on. There they are. Yeah, but grab one of those real quick. So our definition, you can just kind of go along with me here and fill in some of the notes on this. Compound inequalities, the definition is multiple inequalities at the same time, and two of them at the same time, so we're going to be working with two at a time, all graphed on the same number line. Okay, so we're going to look at two different types. We're going to look at or compound inequalities and compound inequalities. So let's do just a little experiment here real quick. Let's kind of give us a little insight into the difference between the words and or. And this is in math, but it really in English too. It means essentially the same thing. So raise your hand if you are taller than 5'10". Raise your hand high if you're taller than 5'10". Okay. Raise your hand if you are shorter than 5'7". Raise your hand real high if you are. Okay? Now, listen carefully here. So, a little bit of hands both times. Raise your hand if you are taller than, let's make it tall, let's do it again. I want to make it a little more beautiful. So let's say taller than, raise your hand if you're taller than, what did I say, 5'10"? Say it 5'9". So we get a few more hands. Okay, good. Raise your hand if you're shorter than 5'7". Okay? Raise your hand if you are taller than 5'9" or shorter than 5'7". Should see lots of hands, shouldn't I? Right? So if you're, let's take a couple examples. If you're 5'5", are you taller than 5'9" or shorter than 5'7"? Yeah, you are. You're shorter than 5'7". Or means only one of the statements has to be true. If you're 6 feet, are you taller than 5'9" or shorter than 5'7"? Yes, you are, right? So once again, raise your hand if you're taller than 5'9" or shorter than 5'7". Quite a few hands go up. Okay, now let's try an and. Listen carefully to this one. Raise your hand if you're taller than 5'7" and shorter than 5'9". Not as many go up. Only people that put their hands up now would be people that are in between 5'7" and 5'9", right? That's a shorter range, isn't it? See what I'm saying? Okay, the point is, an and is a more exclusive statement than an or statement, right? It's more restrictive. In order for an and compound inequality to be true, all parts of it have to be true at the same time. So another example, we'll just use our imaginations here. Like if we were to group into one room all of the pets in Pendleton that were dogs or brown. There'd be lots of, any brown fish or bird or cat or any dog would all be included in that one big room. Would be mayhem, right? Okay, now let's take all the pets in Pendleton that are brown and dogs. I mean, there'd be quite a few still, but now it's only brown dogs, right? You get the idea. There's a big difference. You're always going to be more exclusive if it's, if it's an and statement than an or statement. All right, so let's focus on the or statements. So it's more than one inequality at the same time. Well, here's two inequalities, right? Let's color code these so we can identify which one we're talking about. Let's make this one red. How do I say that inequality that's graphed? Just using an inequality. X is what? Good, x is less than or equal to -4. How about this one right here? Looks like it's hard to see, it looks like it's a 1. So x is greater than 1, and we'd connect those with the or symbol, right? The v is the logical or symbol. That's what we use to just replace the word or, is a v, okay? Now, it's not really a v, so don't just, on Moodle, if you just enter a capital V, it's gonna mark it wrong. You actually have to pull it down from the menu. It's on the, I think it's on the division side in the algebra editor. How would I say that using interval notation? So how do I say this one? And always think in terms of the graph for interval notation.
Brackets.
Okay, which kind of bracket?
Uh,
Okay, but, and so, let's go from left to right on this one. What's the first thing I would do? Okay, I need parentheses. Good. Bracket, very good, right? Because this red interval has a right endpoint at -4 that's solid, so we need to bracket, and it's got no left endpoint. The left endpoint's out at -infinity, right? How about the green interval? Good. This one's got a left endpoint that's open, it's not closed, at 1, and no right endpoint. Right endpoint's out at infinity. Okay, now here's the part I want to really draw to your attention here. This is the part where people are going to probably at least once make a mistake on the homework, not because they got the problem wrong, because the formatting is important on this. It's like, when we talk about notations in math, it's almost like a language, and yeah, kind of like a language, or maybe just handwriting, cursive versus printing, or something like that. But they are consistent. So we use the V or symbol when we're using inequality notation, which just means we're using inequalities to write our answer. When we're using interval notation, we need to use the union operator, which it looks like a capital U. And once again, you just grab that from the menu. And if you hover over it, it tells you, it'll say union if you hover over it in the Moodle algebra editor, the drop-down menu. Okay? So to solve or inequalities, we just solve each one individually. It's no big deal. Let's take an example. Like here's an or inequality. 3x plus 4 is less than or equal to 10, or 5x is greater than 45. Okay? So let's break these into two and literally just knock them off one at a time. Right? So we'll take the left one first. What are the two steps to isolate the x in the left inequality? Subtract 4 first. We're just using inverse operations, of course, so that cancels those. And then we get 3x is less than or equal to 6. Good. Last step? Divide by 3. If I divide by 3, I just get x is less than or equal to 2. Okay, so there's one part of my answer. What about the other part? Divide by 5. That's all I have to do. If I divide by 5, I just get x is greater than 9. And do I use a b or a u here?
B.
B, because I'm using inequalities. Good. So this is that's my answer. Hey, Renee. Like this instant, or can I give it to you right after class? Okay, perfect. I'll do that. All right. Bye. Okay, so how would I graph that? Closed circle at 2, okay. Oops. And shade to the left. Good. Good. And notice those are completely separate intervals. That's an or inequality. Remember, when we graph a compound or inequality, I don't know if you've ever heard this before, but compound or inequality, it looks like someone's rowing a boat towards you, and those are the oars on the boat, right? Going out the sides of the boat. Easy way to remember it, okay? So that's always what an or inequality will look like. If I use interval notation, I could break it into two parts. There's the blue part, and, it sounds like you guys already kind of get this part. So that's going to be parentheses instead of brackets, negative infinity, comma 2. What kind of operator do I need for interval notation? Good, I need my union operator. And then I got my red part, which is all the values. Whoops, I messed that up, didn't I? That should have been brackets, shouldn't it? Yeah, brackets. And then the red part should have been, or it is, 9, comma, infinity, right? Okay, let's try another one. Let's get a little more practice. So what about this one? Let's go, let's take this one down here so we can work on it a little better. Okay, so we got two expressions separated by an or two inequalities separated by an or, so we'll just solve these individually. So what about the left one? Good. Let's multiply by -3, which clears the fractions. It's also what we have to do algebraically in this case, but we want to undo dividing by -3. So we're going to multiply each side by -3. Okay, what's that give us? Good, that canceled those guys. That's what we wanted. So 8 minus x. Ah, you caught it. Good. So because we multiplied by a negative, I have to flip that around, don't I? Right? Greater than or equal to 15. Okay, now what? Subtract 8. Good job. That cancels the 8s, and I get negative x is greater than or equal to 7. Now what? Okay, I'm either multiplying or dividing by -1, whichever way you prefer to think about it. Right? So that's going to flip that inequality again. I'm going to have an x there and a -7, and this has got to get flipped again. So what about over here? Multiply by 2, great idea. Let's multiply by 2, clear the fractions. So that's going to cancel those guys. That's, whoops, and I got to distribute, don't I? In fact, going a little too fast. So I canceled the 2 in the second part, but when I distribute the 2 to the 5, what do I get? 10. All right. So we get 10 minus 3x, 2 times -1 is -2. No flipping there, right? I multiplied by a positive, so I don't need to flip the inequality. It's fine. Now what? Those go away, and I get -3x is less than -12. Good. Divide each side by -3. Good. Whoops. Which means I've got to flip that sign around. And so I end up with x is greater than 4. So those are my two parts of the OR inequality. Right? Either x is less than or equal to -7 or x is greater than 4. Yeah. No biggie. And now would once again look like oars on a boat. I'm going to get a ray to the left starting at -7, a ray to the right starting at 4. Makes sense. Okay? Now let's look at and. So and type inequalities. Let's try this one. So this time, now you might have noticed a correlation here. When we're doing problems like this, the number of inequalities determines the number of endpoints, right? There's some weird cases we'll look at the end where sometimes you got to think carefully about it. Maybe we'll get, I don't want to say too much about that. We'll get to the weird cases when we get there. But it's not an accident that we had two inequalities and two endpoints, right? We had two inequalities and two endpoints. We had two inequalities, and if we graphed this one, we would have gotten two endpoints, right? The same thing is true for an and situation. So I've got this left endpoint, which we'll call blue, the right endpoint that we'll call red, and we're shading everything in between. So what's the inequality that corresponds to the left endpoint at -2? How would I say that? X is what? Greater than or equal to -2. Good. Now, the word and, I'm just going to include right now. We'll maybe find a symbol for that in a second. And what about the red endpoint? I want everything to the left of that endpoint. Then 5. Good. Okay, and everybody agree? That's going to include both endpoints and everything that's in between. Okay, the stuff in between, those are the values that are pinched between, or greater than -2 and less than 6. I'm going to include that endpoint. So using interval notation, look how good this is. Using interval notation, this is really simple. We just end up with square bracket -2, comma, 5 open bracket. Works perfect, doesn't it? This and inequality stuff fits perfectly with interval notation, right? Our left endpoint shows up on the left, our right endpoint shows up on the right, and we're in good shape, okay? So we don't really like to use the word and though, so let's fix this. So one step better than this would be to say x is greater than or equal to -2, and, so just to flip over the v to create an and, like an upside down v, and x is less than 5. But best of all, this is the way we really want to write it, is as a single compound inequality with 3 parts that matches the interval notation. I'll start in the middle and I'll say x is greater than or equal to -2 and less than 5. Look at that. That's really good, isn't it? Right? Now, we don't read from left to right. We don't start at the -2 and say -2 is less than or equal to x, which is less than 5. We don't do that. We start in the middle and say both of them at the same time. X is greater than or equal to -2 and less than 5. And that tells us what that double-ended interval is, right? It matches up perfectly with our interval notation. Okay, so let's try a couple of these. We'll do one kind of hokey one with the word and in it, or a symbol, and then we'll start looking at the kind that we're more interested in, where we've got it written in 3 parts, which is almost always how we do it in math. So what are the 2 steps to isolate the x in the first one? Good, so we do that. 2x is greater than -12, divide by 2, and we get x is greater than -6. And for the word and, we'll use our symbol. Add 2, so we get 8x is less than 32, divide by 4, and I get, divide by 8, sorry, and I get x is less than 4. That's how I could say it using the word and. But we really don't want to write it that way. How could we write that better in 3 parts? And good. And we could just say x is greater than -6 and less than 4. right? And that's the way we really want to do it. And once again, this is really easy to graph. I get -6, open, 4, open, shade in between. And the interval notation matches right up with that, doesn't it? We get -6, comma, 4, parentheses on both sides. Right? Okay, let's look at maybe one more just for maybe 2. What would the steps be? We can do this really quickly. What would the steps be? What do you think we're going to do? What are the steps to isolate P here? 2 steps in order. Subtract. What are you right? Subtract. To get that P by itself, what are we doing? Subtract 4 and then divide by 3. Okay, in that order. We got reverse order of operations. So but we got 3 parts to it. So what do we do?
Subtract 4 on both sides.
Everywhere. All 3 parts we treat the same. Subtract 4. Let's get Chromebooks closed. I want everybody to focus up here. Even if you think you got this, you might. There's a couple other things I want to show you that are going to be a little tricky. So we subtract 4 everywhere. That gives me 0. I get 3P. I get 15. Last step.
Divide by 3.
Divide everything by 3. Okay, so then 0 divided by 3 is 0. 3's cancel. I get a P. I get a 5, nothing flipped. So that's simple. There's my solution. 0 is great, or P is greater than 0 and less than 5. It's pinched between 0 and 5. Okay? Okay. What about this one? This is a little tricky, right? Good idea. Really good idea. Let's multiply everything through by -2 right away. So that's hard to, I don't have a lot of room to show that, but I'm just going to do this. We're going to multiply everything by -2. Okay, by -2. So what am I going to get here if I multiply by -2? Positive 10. Here it's going to cancel the -2, and I get 12 minus x. And here I get 4. Okay. Oh, we got to be careful about it. Have to flip the side. Okay. We'll keep going. Now what? Subtract 12. -2, -x, -8. No flipping that time, right? Then last step? Yeah, I'm going to multiply everything by -1 to change all the signs, which means I got to flip the inequalities. So that becomes a 2, an x, and an 8. And these things are going to get flipped. And so that's my answer, isn't it? X is greater than or equal to 2 and less than 8. Okay? So then, not so bad. I want to show you just a couple more quick examples. Okay, I'll let you work tomorrow if you don't get any time today. So how about this one? Am I okay to move this? Everybody caught up? Okay, so how about this guy? What if I give you another example like this? The algebra is really simple. That's not what I'm focusing on. I'm focusing on how do I interpret the answer. So what if I start off with -10 on the left, -2x, and -4. So -2x is greater than -10 and less than or equal to -4. What's the one step I got to do to isolate x? Okay, good. Divide everything by -2. Red flag. So that's gonna give me
50.
5, good. Here I'm gonna get an x, here I'm gonna get 2. What do I need to do? Flip the signs. Okay, so that's technically my answer, but that doesn't look right, does it? That doesn't look like the other examples we got. Look at all these other examples, the variable's in the middle, and I got a smaller number on the left and a bigger number on the right, just like the number line, right, like our graph. All those examples, that's what we saw. So what do I probably need to do here with this one? Okay, good. I got to put the endpoints in the correct places, don't I? Right? I've got the x in the middle, but I really don't want, I want the 2 over there and the 5 over there, right? And so now, yeah, what are my relationships? Well, I've got this, how is x related to 2? Well, x is greater than or equal to 2. There's my greater than or equal to sign, greater than or equal to, right? How is x related to 5? Whoops. Is this not? There we go. X is greater than, or less than 5, right? There's my less than sign. Now it looks good. Now this matches up with interval notation or the graph. The 2's on the left, the 5's on the right. Okay? Okay, a couple other just tricky ones. A couple other sort of tricky ones here. So what if I did something like this? What if I did, now think carefully about this. There's very little math, there's no math to do. You just have to interpret this. What if I make the statement x is less than 1 or, I'm going to say greater than. X is greater than 1. Just like a comedy of errors. X is greater than 1 or x is greater than 3. What's the solution to that? Can I write that more simply? What's the simplest way to write one?
X is greater than 1.
That's an or. But let's graph it and see what you think. Let's graph these two inequalities and see if the graph helps us understand what's going on. So there's x equals 1, there's x equals 3. How do I graph x is greater than 1? How do I graph x is greater than 3? Okay. Well, an or statement is true. Do both have to be true or just one? Just one. So what's the easiest way to say all of the places on either one of those two graphs, blue or red, would just be that, wouldn't it? Everybody get that? So I could simplify that by just saying x is greater than 1. Everybody agree? Okay. Now let's compare that to the statement, almost the same problem. And now let's do x is greater than 1 and x is greater than 3. Solution to that.
Oh, that's the x is greater than 1 and.
Right? I mean, that's true. That's what we got. X is greater than 1 and x is greater than 3. But can I say that more, can I simplify that? Let's look at some, is it true for 5? Is 5 greater than 1 and greater than 3? Yeah. How about 2? Is 2 greater than 1 and greater than 3? No. 0 wouldn't work. X is greater than 3 is the solution, isn't it? How come? It's the only intersection of those two graphs, or that's the only place where both of those graphs are drawn at the same time, the only place where they overlap or intersect, right? That's not what I was looking for up here. Up here, I'm not looking for the intersection, I'm looking for the union, which is any place where any of those graphs ever exist, right? All taken at once. Right? How about this one? What if I do x is greater than 1 or x is less than 3? So it's that, right? And x is less than 3. Look at that. What's the solution? What values of x are greater than 1 or less than 3? Can anybody find me a number that is not one of those two things? 2 would work. How about negative 10? Is negative 10 greater than 1 or less than 3? It is. Less than 3, isn't it? How about positive a billion? Is positive a billion greater than 1 or less than 3?
Yeah.
Yeah, so what's the answer this time?
1 or greater than.
All reals. Yeah, because every place on the number line is either blue or red, right? So this one would be all reals. Okay, now let's look at another example. What if we said this? What if we said, last one, x is less than 1 and x is greater than 3? What do you think? What's that going to be? Less than 1 is to the left of 1, greater than 3 is to the right of 3. Somebody find a number for me that's less than 1 and greater than 3.
There's not.
Give you $1 million if you can do it. Can't do it, can you? Right? So that one's going to be empty set, right? No solutions. Okay. Now you'll notice on the, so how would we write that? No, we already did this stuff. Yeah, we're fine. I don't think we'll go back in. I think we're good. Questions? Okay. I'll let you, might as well get a little bit of work done here. Open up those Chromebooks.